And so this is going to be part 2 of day 11. I actually did algorithms in the morning, but I'm going to be doing more algorithms today, but I'm going to be doing data structures as well. That's something I have to get better at. Tomorrow I actually have a coding test. What am I trying to type? Stream chat. Okay. Um, I have a coding test, so I gotta get better. So I did algorithms today. What I'm gonna do is a little bit of data structures. I'm trying to get binary tree today. So data structures I kind of gotta get better at. I don't really have a computer science degree, so this is stuff I just have to learn myself. I'm gonna be doing this. This is free code camp. I'm gonna be doing for my music. That's not how I wanted to put my music. Headphones. Okay, so I'm gonna be doing. Okay, so I'm gonna be doing free code camp. I'm gonna be doing free code camp stuff, data structures, and then I'll probably switch to an algorithm or something like that, or I might just stick to data structures today. So I want to do. So I'm gonna look at. So I'm trying to do this today. I'm trying to do linked list, and I've been working on this before, but I have to review it and learn more about it. And I'm gonna be doing this and the binary. I'm gonna be doing this and trees. So let me see how far. So basically, I have to get this one. I'll try to get as far as I can. I'll see what I could do. It's later in the day, so I don't know. I'll see how much energy I have. I just want to see this right now. I'm gonna review this. Yeah, let me type. This is a new mic stand, so I'll still have to figure out how this works. Also, it's a new mic cable, so I'm trying to see if my volume is good on this. Linked list, JavaScript. Okay. Linked list, JavaScript. So if anyone's watching my channel, I was able to do jujitsu today. I haven't done it for 2 months. I'm back. I'm somewhat healthy. Um, so, actually, I'm gonna put something in my description of a really good book that I found for data structures. So it's JavaScript specific data structures. So, I'm gonna try to put it in my description. Let me see. I might do that right now just so I don't forget. It's going to be in. Let me see. So I'm going to. So the book, if you guys want to see, the book that I recommend. So I went to Barnes and Noble the other day, and I found this book, JavaScript Data Structures and Algorithms. So I found this book. Let's see. It's this one, yeah. So this book, I went to Barnes and Nobles, and this book, I might buy it. I haven't bought it. I saw it in Barnes and Nobles. I liked it a lot. They don't have it. I live close to New York, so I went to the one in New York, and they had it. But I live in New Jersey, so they don't have this here. So I'm gonna put this in my description really quick. So if you guys want to take a look at that, it's gonna be Amazon affiliate link, so I get a small percentage. But you could do the same thing that I do. I just yeah, all I do is go to Barnes and Nobles and look at the book. But this one I might buy. Yeah, so right now I have it in my YouTube description. I'm gonna just update my Twitch description really quick. Switch. I also have Mixer, but I don't even have any subscribers yet for Mixer. Twitch TV. Okay. Let me edit my panel. Let's see. So let me see really quick. So data structures. I'm just putting it in my description. Just give me 1 second if you're following live. Let me get this. I think this is the correct way. You update it, check it, and then I'll start doing data structures. So I saw this book yesterday actually. Is my panel updated? Oh no, it doesn't work. I did something wrong. Oh, I know why. I didn't wrap it in let's see. Wrap it. Let me wrap it, and then okay. So submit. I'm just doing that, and I'll get started in a second. So yeah, this book I recommend. What I'd usually do is I kind of do free code camp, and then when I get lost or confused, I kind of just go to Barnes and Nobles, or like when I don't feel like being in the house, I go to Barnes and Nobles. I think I have it now on Twitch. Let me see. Yeah, so like I have it clickable on Twitch. So if you wanna, or on YouTube, you could click that, and I'll start in 1 second. So like I was saying before, tomorrow I have a coding test. My coding test is gonna be on HackerRank. So what I'm gonna do is, so I have here HackerRank. Actually, let me switch my screen. So HackerRank has something where you could kind of prepare for the interviews, and it's gonna be for front end. So I have to kind of know React well. I have to know it's a Redux job too, so I probably have to know that, but I don't think they're gonna test me on that. And I have to know probably like algorithms. So all these algorithms that I've been doing should definitely help me. Because I just started doing algorithms again like 2 weeks ago. I kind of took like a few month break doing like WordPress and PHP. So this is what I have to do. I'm probably gonna do this for data structures and free code camp, and then I'll switch to this. You guys can follow this along too if you want to see. This is just HackerRank interview preparation kit. So the things that are probably gonna be harder for me are the like graphs and trees, and like these kind of stuff are a little harder for me. I think the regular algorithms, I think I should be fine. So let me just review stuff with graphs. If you guys see that I'm doing something wrong, or if you have suggestions or whatever, I happily take suggestions, especially with this type of stuff. Is my mic okay? So let me read again. Let me review my mic. Okay. 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 So I have. Okay, so this is kind of just making the node. So I remember I read yesterday, for linked list, you make a class, and you're making 2 classes. You're making the node class, and you're making a node class, and you're making the actual linked list. So let me read this. So this is to make the node class. Okay. Another common data structure you'll run into in computer science is the linked list. A linked list is a linear collection of data called nodes, each of which points to the next. Let's write it down. Linked list is a linear collection of data elements called nodes, okay, each of which points to the next. Okay, so I have here var node function. Okay, so I already did this, so can I just go to the next one? So I kind of understand that. Actually, let me write it out. So like what I was saying before, this is gonna be to make the node. So I'm just gonna write that out so I kind of have it in memory. So let me write it down. So this is to create the node. Var node equals function, and then the element. So okay, so it's gonna be this dot element equals element. Okay, I get that. Element. Okay, this dot next equals null. Okay, so I did this. I already made this. I'm not gonna make this. So where is it? This isn't coding. So if you guys want to follow along, you could go to free code camp, and then I just go to the bottom, coding interview prep. So I go to data structures, create a linked list class. So okay, let's look at this. I actually made this already, but I have to review it. Sorry that I'm kind of like coughing. So create a linked list class. Okay. So let me write this down. So create a linked list class. So okay, let's create a linked list class. Every linked list should start out with a few basic properties: a head, okay, a head, the first item in your list, and a length of items in your list. Sometimes, okay, length of items, okay, head length. Sometimes you'll see implementations of linked lists that incorporate a tail for the last element of the list, but we'll just stick with these two. Whenever we add an element to the linked list, our length property should be incremented by 1. Okay, we'll want to have a way to add items to our linked list, so the first method we'll want to create is add method. Okay, in our list, if our list is empty, adding an element to our linked list is straightforward enough. We just wrap the element in a node class. Okay, we assign that node to head of our linked list. Okay, but what if our list already has one or more members? How do we add an element to the list? Recall that each node in a linked list has a next property. To add a node to the linked list, find the last node in the list and point the last node next property. Add our new node. Hint: you'll know you reached the end of a linked list when a node's next property is null. Okay, so what did they? So I've actually did this one already, but I have to review it. I have to just keep reviewing it until I'm good at this. So let's see. So write an add method that assigns the first node you push to the linked list to the head. Okay, write an add method that assigns the first. Okay, so I have, so this is our linked list class. Var length, or this is our function. Var length 0. Okay, because we don't have anything. Var head, we don't have a head yet. Var node equals function. Okay, so this dot head equals function return head. Okay. Okay. This dot size equals, okay. So we're gonna do it here. So, and we have to do something. So we have to kind of first check if there's anything in our linked list. Okay, write an add method that assigns the first node you push. The right write an add method that assigns the first node you push to the linked list to the head. Okay. This dot add. Okay. I'm probably gonna have to look stuff up for this, but let me see how far I could get without looking stuff up. If our list is empty, adding an element to our link, we just wrap the element in a node class. Okay, so I'm gonna have to check. So do I check? I think so. So I have to do. So I have to check the head if it's null. But I'm gonna get a hint for this. Let me see. Is this what it is? Oh no. So I'm gonna look at the side really quick. I'm gonna get a hint. Link list free code camp add. So like in my head, I think I do. Like I know I could just do like an if statement, but I want to see if that's the correct way. I think they have this on GitHub. The answer. Okay. Oh, I was correct. Okay, so if head equals null, if head equals null, okay, I get this part. So if head equals null, so if there's no head equals new node element. Okay, got it. I got that part. Okay, now else. Okay. Oh, I spelled else wrong. So okay, else. Let me see. So let me try to understand this. Else. Now else I have to find. So while let me see how much I remember. While damn. Okay, so I have to look at it. Okay. Else. Okay. Else. Okay. Let current node equals head. Okay. So we're gonna start at the head. Okay. Now, if current node dot next doesn't equal null, so if it's not the last item, current node dot next doesn't equal null, current node equals, okay, current node equals current. So we're just going to the next node, the next node, the next node until it's the last one. And then we do okay, wait. Current node equals current node dot next. Okay, so we keep going to the next one. Current node dot next. Oh, so we're in the last element because it's null. So we're in the last element. Okay. Now this makes sense to me. Current node dot next equals, now current node, the next node equals node element. Okay, got it. Then we just increase our length. Let me see. So we do it length plus plus. Okay, so this should work. It should also work because I'm copying it, but okay, I'm just gonna go to the next one, even though. So now I gotta see. Actually, I did this one, but I have to have it in memory. My neck is a little kind of like off. Okay, so the next one is coding interview prep. The next one is removing items. Okay, so take home project, data structures. Okay, data structures. So I'm gonna have to remove. Okay, let me just. I'm writing a plan out though. So my plan is gonna be to get real at this week. To get really good at linked list. So I'm gonna write linked list, and then probably next week binary search. I'm just gonna write tree. Next week tree. Also, I think I have to learn about like dynamic programming. I kind of learned that the other day. I kind of understand it a little bit. Like I get the concept, but I don't really know how to do it. Okay, so now we're doing the same thing, but we're removing. So, let me read it. Okay. I also take Muay Thai classes, but I definitely can't do that with my leg right now. So remove items from a linked list. Okay. So the next important method that any implementation of a linked list will need is remove method. This method should take the element we want to remove as an argument, and and search the list to find and remove the node that contains that element. Whenever we remove a node from a list, it's important that we don't. Whenever we remove a list from, it's important that we don't accidentally orphan the rest of the list in doing so. Recall that every node's next property points to the next that follows it in the list. If we're removing the middle element, say we'll want to make sure that we have a connection from that element's previous node next property to the middle element's next property, which is the next node in the list. This might sound really confusing. Wait. I'll read that again. Whenever we remove a node from the list, it's important that we don't accidentally orphan the rest of the list. Okay, I get that. Remove that. Recall that every node's next property points to the node that follows it in the list. Okay, I get that. If we're removing a node from the middle element, say, we want to make sure that we have a connection from the element's previous node's next property to the middle element next property, which is the next node. Okay. Okay. This might sound really confusing, so let's return to the Conga line. No, I get it. It's just I gotta think how to do it. This mic. I gotta put like more like Loctite on this. Okay. Why does it? Come on. Let's see. So let's put this over here. Oh, come on. Why? Does it still hear clearly from here? Like, or do I just hello, hello? Oh, hello. Or is it hello, hello, hello? Oh, it still hears kind of clearly from here. It's just I don't like it. Okay. So this might sound this might sound really confusing. So let's return to the conga line example. So we'll have a good conceptual model. Picture yourself in a conga line, and the person next directly in front of you leaves that. Okay, I get that. The person who just left, the line no longer has hands on anyone in the line. You no longer have hands on the person that left. You step forward, put your hands on the next person. Okay. If the element we wish to remove is head element, we reassign the head element. Okay. Let's see. So this dot remove. So okay. Okay. If head equals element, if head equals element. So if we're removing the first one, how do we remove it? So if I remove it, so if I remove head, if head equals element, if head equals element, okay. If head equals element, head dot next equals head, right? Okay, so that, I think this is what I do. Head dot next equals head. Head dot next equals head. Okay, is anything not missing? If so, else, okay, else let current node equal head, while current node dot next while current node dot next equals element, right? While current node dot next equals element, while current node, I don't know, if it doesn't equal element, if current node dot next doesn't equal element. If while current node dot next equals element, current node equals current node dot next. Okay, I'm getting this from memory, so that's good. While current node, okay. Now we're trying to remove. So we're trying to remove. So if I have, okay, let me just, so I have my element. Okay, so I have my element. So if current node, if current node dot next doesn't equal element, okay, then okay. Wait, sorry, I gotta kind of rethink this. Okay, so current node is head, so if current node, so if we're looking at the next item, and if the next item doesn't have the element, we're gonna go to the next one. Okay, until the next item has the element. Okay. So I think I could just do current node dot next equals current node dot next. So we're kind of just skipping over it. But I don't know if I'm really deleting. Okay. So I don't think this is 100% correct, but it's what I have right now. And I'm gonna check how they have it. Let's see. Data structures. Let's see. I'm gonna remove current create a hash list class. Control remove. Come on. Remove element. What does this say? So I'm just looking at like the answer really quick. Okay. So let's see my answer compared to does it work? So what does it? Okay, so there's stuff that I didn't do correctly. Okay, so so the remove. Okay, so the thing that I didn't do. So this dot. Let's see. So they want me. So this dot remove function and then index. Okay. Let me see. Oh, so this is the answer. So let's see. This dot remove at current node head or previous head count. So current node equals head. Okay. Previous var previous equals head. What? Var count equals 0. So if index is okay. I'm probably gonna have to sleep on this. At least, okay, so yeah, this takes me a little bit of time. Let's see. Actually, it might be done for today. Let's see. Maybe I'll stream me and myself playing Japanese games or something. Anyway, so if you guys are studying web development or programming, if you're new to web development, I have a few good books listed on my Twitch and YouTube. I get a small percentage, so if you click them and you buy them, that would be nice. But you don't really have to. You could just buy them and go to the library or just go to Barnes and Nobles. That's what I usually do for the books. But the books are really good. So if you're just learning HTML, CSS, JavaScript, React, PHP, any of those books are really good. I highly recommend them. Actually, I added a new one for data structures and algorithms, and I'm looking at that now. So I recommend those. And if you're trying to learn web development, trying to find the job, good luck. Hope my video motivates you. It definitely motivates me to make it. If you have any comments, suggestions, let me know. If you have things, suggestions for stuff that I should learn also as well. Also, if you have questions, let me know as well. I usually give good advice for people just starting. And I think I'm gonna be done. Anyway, good luck, take care, and keep programming.